All right, thank you everybody for joining us today. We're really excited to be talking with you today on how we can help you cut idle time on your service vehicles by at least 50%. So my name is Jimmy Fielding. I'm sales application engineer for Purkeys, and joining me today is Todd Self. He's director of sales business development for Zero RPM. But before we get started, I wanted to kind of give you everyone a quick little overview of Purkeys and our relationship with Zero RPM. So about 3 years ago, Purkeys joined the Mission Critical Electronics family, which is comprised of multiple companies whose focus is to deliver quality electronics for hostile environments across various markets. Some of you may know that Purkeys is well known for charging and protecting batteries, such as liftgate batteries or sleeper cab batteries with our inverter systems, in Class 8 tractor and trailer market. We really didn't have a whole lot going on in the service vehicle area. But when Zero RPM joined Mission Critical family about 2 years ago, and as we started working closer and closer with them, we quickly realized our visions aligned. And together, as we work together, we can work together to significantly reduce operations and maintenance costs. That was the biggest thing. We both, that's one thing we both do as companies, and we can do that responsibly and protect our environment in the process. So with that, I'm going to go ahead and turn it over to Todd Self with Zero RPM, and he's going to walk through the Zero RPM solution with you.
Great, thanks, Jimmy. So, again, my name is Todd Self, and we're going to talk about a product that we call an idle mitigation system. What we are focused on is trying to find an alternative to idling an internal combustion engine for power and comfort of the chassis cabin or the body of the vehicle while in a stationary use. So we're going to start off with a little bit of a business case consideration that we like to go through. And to do this, we're going to use some numbers and we're going to make some assumptions. And one of the assumptions is that the majority of the vehicles we've got our systems on, they see it about 50% of their time are in park and used in idle. Okay, so that's, of course, we're targeting vehicles that idle more. So I know that's not necessarily representative of all the vehicles and all the fleets, but and then we're also looking, the math we're going to run today is based on an 8-hour workday. So based on those assumptions, one thing we wanted to discuss is how do you use your vehicles? And I think Jimmy's going to use some poll questions here.
Yeah, so just a little bit of interaction with the group. This is a poll question. So how many hours a day are your service vehicles on duty? So you can select A, 8-hour shift, B, 12-hour shift, C, 24-hour shift, or D, other. So we'll give you a few seconds to answer that. And if you choose other on the the previous question, how many hours are your service trucks on duty? So if you can enter your answer there, go ahead. So we'll give it a few seconds and let everybody answer. All right, so I'm going to move on to the results. All right, Todd, look at here. We got 8 hours, 33% say they run an 8-hour shift, 0 on a 12-hour shift. And then we have 33% on a 24-hour shift.
Okay.
And we do have some other.
Okay.
Oops, we'll go back. So yeah, we kind of gives you an idea, gives us a really good idea of
Right.
how many hours your service vehicles are on duty. So I don't know if you have anything to kind of add to that, Todd.
Well, no, just one of the things that obviously, when you're building a business case for a system like ours, it's in cost avoidance, right? So if the cost avoidance is based on a longer use business or a longer use case as far as time. So if it's an 8 hour shift, then you have less opportunities for us to create cost avoidance than you do if it's a 24-hour shift, of course. So that goes into kind of the calculations that we'll use. We always try to use the most conservative, which is what we've done today. 4 hours of an 8 hour shift would represent a typical customer of ours that's in a high idle application on a shorter workday. So it'll kind of give us an idea of when you're looking at this data as we go through it, kind of how to extrapolate that to how it would apply to your fleets.
Very good. So something we don't normally do often, we had 2 poll questions back to back, but always like these poll questions and like the feedback from the group. The next one is, considering the amount of time your service trucks are on duty, how much of that time do you estimate those trucks idle? So we got A, 25%, B, 50%, or C, 75%. I'll give you a few seconds to answer. And also throughout this webinar, please submit any questions in the Q&A section. While Todd and I are speaking, we're happy to address those questions on this webinar. All right, so moving on to the results. 33% say 25% idle time. 66% say 50% idle time. So that's very interesting. That's kind of the sweet spot for us, right, Todd? The 50 to 75%.
That's right. Yeah, we start seeing the bigger. That's right. More aggressive business case at that point.
All right.
So when you consider those numbers, taking those numbers into consideration, this is again based on an 8-hour workday, idling half the time. That's going to be 4 hours out of an 8-hour day. We're also going to make an assumption of gallons of fuel wasted as a gallon. Obviously, a Ford Transit is going to idle at a different rate than a M2 Freightliner, of course, but it's going to be somewhere between a half a gallon and a gallon and a half. So we just use 1 gallon to make the math easy. I'm from Alabama, if you can't tell by my accent, so I like to keep my math easy if I can. So we also are assuming a 250-day work year, and again, 1 shift a day, so 1 8-hour shift a day. So all we're trying to do, and we're going to use the same calculation inputs as we go through this to say, look, it adds up more than you might think, right? So idling is obviously wasting up a lot of fuel. If we're assuming that's $3.50 a gallon, which I know is also another moving target, over a 5-year period of time, you can waste 17,500 hours worth of fuel using those assumptions. One of the biggest things we talk about a lot, though, with fleet operators is the wear and tear. And Ford published a number some years back that says for every hour of idling, it has an equivalent impact of 33 miles of driving to the chassis. So when you take that ratio, when you take that same math, that adds up to 165,000 miles of wear and tear that's not on the odometer, but it's impacting the life of the chassis, right? So there've been some talk in recent times of some of the NTA events I'm sure you guys go to, measuring events and all. Some of the manufacturers are saying, that 33 miles is right if you're looking at idling intervals throughout the day, but long continuous events of idle can have exponentially more impact, right? So if something is in a situation where you can idle, an hour or 2 continuously, then all of a sudden that equivalence the number can go up exponentially based on heat and other things that's going on there. So anyway, it adds up. That's all we're trying to say. Obviously, there's a consciousness like never before of the impact all this has to our environment. And when you think about that same calculation using the same assumptions, we're having a 55 tons of CO2 that we're creating and putting in the atmosphere to idle the engines. So, the case we're trying to make here is idling is wasteful and it's not good for us, right? And there's some things that we should try to do to try to, mitigate that as much as possible. And that's where our solution comes in. We call it an idle mitigation system because we understand that some idle is necessary, and we'll get into why those might be. And then we also get into how we automate the process of trying to manage that idle for you as much as we can. So obviously, kind of a little bit redundant here, but just to make sure we're clear, what we're going to be doing is we're going to be turning that engine off automatically anytime it's in park and using our power as an alternative. So an engine that's off is not going to be burning fuel. It's not going to be creating wear and tear that's going to increase your operating cost. And obviously, it's not going to be creating emissions. So we can have a reduction on your emissions that you're creating with your fleet. But all that boils down to, the vast majority of our applications are going to be situations where they idle the majority of their time because of how they use the vehicle. And the vehicle is their refuge from the environmental temperatures or, to do their work. It's their office. It's like a mobile office where their paperwork's done, things like that. So operator comfort and safety is where we've spent the majority of our money, and the IP around our product has been about making that vehicle behave as if the engine stayed on. So there's no compromise to the user as far as air conditioning and heat and using the electronics on board. Some of the vehicles, that's not a priority, and we can do only export power and the cab is off, just like the engine was turned off and the cab temperature is not maintained. In the vast majority of our customers, the applications that we typically serve, that is a priority, and a lot of our technology is around how we keep that chassis cabin as if the engine never turned off.
Great, thanks for that, Todd.
Yep.
It's a good segue into this poll question for the group. What is your main reason for idling? So we've got a few selections here. A, running tools and equipment. So running all the equipment in the box. B, keep vehicle batteries from draining due to vehicle accessories, such as radios, basically any accessory in the cab. C, safety and comfort in the cab, like Todd just mentioned. Or D, all the above. We'll give you a few seconds to select your answer. We'll kind of go over that. Looks like we still have a few of you submitting your answers. We'll go ahead and review the results. So yeah, we see 20% of you running tools and equipment, whether that's in the bed of the truck, running, air compressor, charging, hand tool batteries, that sort of thing. 20% of you, say safety and comfort in the cab. And then 60 of you said all of the above. Kind of the key to all of this is, this system's scalable. We can provide power. Just like running tools and equipment, we can provide all that power for you. We can also provide, like Todd mentioned and explained, all the comforts in the cab for the operators. Again, like he said, just like with the engine running, we can still provide all those safety comforts. And kind of, Todd, you can kind of expand on that a little bit. But from your experience, and with customers that are running the system, that comfort factor and having all the the heat and air, everything inside the cab, you really get a lot of good feedback from that. And from the operators that are using the product. Can you expand on that a little bit?
Sure, certainly. And you know, let's be honest. I mean, there's been a lot of attention drawn to internal combustion engines and alternatives to internal combustion engines, and idling specifically is one of the things that's really in the last several years, last 3 to 5 years especially, there's been a lot of emphasis put on different fleets to control idling, uh, telematics, different types of tools being used to try to manage that as much as we can. And wasting of idle is something that can just be as easy as training your people to turn the engine off. You don't need a system for that, right? You just need discipline. But when that vehicle is their mobile workstation, it's their mobile office, it's their refuge from the environment, then all of a sudden idling the engine becomes almost necessary in some cases if the crew is outside working in extremely hot temperatures or extremely cold temperatures, or if they've got paperwork to do, things like that, while inside being powered by the vehicle, they want to, be in some level of comfort while they do that. So our system becomes more and more about making that vehicle behave as if it was idling. So there isn't any kind of compromise to the end users. And we all know it's harder and harder to keep our staffing now as much of an issue as sourcing vehicles was 2 years ago or whatever. So it's a challenge to keep these fleets on the road with operators inside them and keeping that fleet vehicle something that can be used whether the engine's on or off. We're able to get the best of both worlds is our goal there.
Yeah, you're exactly right. It's harder and harder every day to find drivers and keep drivers, and that's one good feature of the ZRPM system is you can have that. But the key to that, to all of this is it is scalable, and we can provide exactly what you want, whether it's power and the comfort.
Yeah. I'm going to segue on to the next part of this, and so the use of our system, how you use our system is pretty straightforward and simple. You put the vehicle in park, and you use the vehicle the way you would normally, right? So everything automatically happens, and anything that's powered by the vehicle continues to be powered when the engine is off. Okay, I'll mention this a couple of times in the presentation. EPTO is a prominent part on the screen here, and we do have the technology and experience to adapt to an electric PTO alternative. That is a very case by case. That's not something that's out of the box and you plug it up and it works. It's something we need to work with the builder of the truck and make sure we're sizing all the components correctly for those applications. But that is one of the things that we can provide. But mainly, what most of our systems are out there doing today is they're providing all the power that the engine would be providing if you were just idling the engine. And to kind of get more in the details of that, one of the first things we always obviously have to explain is how do you do this, right? So this is the analogy we try to use is when the engine is on, you're only using the serpentine belt unless there is a PTO engaged, right? So if you may have a 300 horsepower engine that's got a burn rate of over a gallon an hour in idle, and the only thing it's really powering is the devices that's attached to the serpentine belt on the front of that engine. So the main three items that you're using at that point is going to be an alternator for powering the vehicle. It's going to be a coolant pump that's moving the heated coolant from inside the engine block and circulating it through the heater core to heat the cabin of the chassis, right? And then also a belt-driven compressor, air conditioning compressor, that's being used to create, move the freon through the HVAC infrastructure to create air conditioning, okay? So all we're doing is we're taking solid state technology and we're saying, all right, we've got batteries that have stored the energy that's being created by the alternator, by a shore power connection, if it's available at times, by solar, if that's available and that's built into your design. Whatever method we charge those batteries with, that energy's been stored in those batteries. And when you put the vehicle in park and we turn the engine off automatically, now those batteries discharge that power onto the vehicle just as if the alternator would do if the engine was on. Also, we've got a little DC electric pump. And in some cases, in colder climates and in certain use case applications, we'll use like a Webasto or Aspar fuel operated furnace. But in either case, it's electric. It's got an electric motor that's going to move the coolant throughout the engine block to keep the engine block coolant moving through the heater core. And if we're not using a third party little fuel fired furnace, and even if we are, our software is always monitoring that engine block temperature. If that coolant temperature gets lower than it needs to be a suitable source of heat, then we'll just restart the engine to heat it back up again. So we'll start and stop the engine based on the condition of the batteries, and we'll also start and stop the engine based on the condition of that coolant temperature to make sure that we're able to keep the cabin warm as we need to. Again, keeping no compromise away from the operator. And the air conditioning system is probably our most unique. Most of our IP is around that and how we do it. There's a way that we mechanically tie into the air conditioning system through a little check valve, it's a mechanical check valve, and some software and how we tie into to the dash. But when you turn the blend door to blue and you want cold air out of the factory vents, then our compressor will come on instead of the belt driven compressor being turned, and we'll move that coolant throughout that infrastructure just as if the belt driven compressor was doing it. So everything on the right side of your screen is our system using electrical powered components. Everything on the left side of your screen is mechanical driven components by a belt off the front of the engine. And this is oftentimes where a lot of our question comes up if we're given a live meeting and we're in person. So we wanted to follow this up by another poll question if we could, just to make sure we're connecting the dots here.
Yeah. Thank you, Todd, for that explanation. I think, I completely understand it, but I've been around it a little while now. So wanted to throw this poll question in here. Actually, it's a statement, just to see if everyone on the webinar understands. So while the 0 RPM system is running, the truck engine is completely off without belts running, turning anything like alternators, compressors, or pumps. So A, true, B, false. So we just kind of want to get an idea from the group to make sure everybody is on the same page and understands how the system works. Couple more seconds. A few people still submitting their answer. All right, we will review the results. So 100% of the group said true.
Good deal.
So it seems like you explained that very well, Todd. So
well, it's I don't underestimate it, because it's one of those things that I had to say it for myself the first time that the engineers explained it to me when I was coming on board. So
same with me.
So as far as interface of the user to our system, what they would see, the batteries and all the technical stuff is going to be hidden away from their workspace and out of the way. But the thing and this is actually even optional itself, but what would represent the system to the operator would be this display screen if you choose to use it inside your vehicle. And what would happen is when you put it in park, it's going to start a timer, and it's going to come default at 5 seconds. So let's say they pull up to a job site to do their work. They put the vehicle in park. They get out and leave the engine on like they normally would. And while they're walking away, the engine would turn off. Right? That would be a normal way this would seem to operate. And we're going to check conditions of our lithium batteries. We're going to check the condition of the cranking battery. We're going to check the condition of that coolant temperature we was talking about. Once all those parameters are okay for the engine to turn off, then we're going to turn it off, and based on that little timer, in case they're in the vehicle, they'll know what's about to happen. Once the 0 RPM screen comes on the display, it just lets them know that 0 RPM is powering the vehicle and not the engine. Let's say it's a Ford Transit or really any gas-powered vehicle. if you're in a gas powered vehicle and you got your air conditioner on or the heat on, the radio on, and whatever, and you're working on your laptop, um, you'll think the engine's on. You won't be able to differentiate between the two. And if you go to put it in park, I'm sorry, if you go to put it in drive, when you press the brake pedal, will automatically start the engine, and you can put it in gear and drive away. If 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 there's any confusion about the status of the engine, then this lets you visually verify that whether the batteries are powering the vehicle or the engine is powering the vehicle. So, kind of getting into some of the features and explaining some of the benefits of our system as we go. We've talked about how we can air condition the vehicle and heat the vehicle without the engine being on. The lithium that we use is a lithium iron phosphate technology, chemistry. So it's the safest form of lithium. This is not a thermal runaway type scenario of lithium. It's a little less efficient as far as space and power density. So it's used more in industrial applications like this. I will say that I've read some things lately that's really encouraging that more EV manufacturers are coming back to lithium iron phosphate. They found ways to manufacture it in smaller form factors. So that's going to drive a lot of volume in this area of this technology. So we all know what that means. It means we can help to drive the price down as adoption rate begins to increase. We've been using lithium iron phosphate. We've been in business for over 12 years now, and we've been using it since the day we began because of its safety. And we use a lot of our applications in really high current output applications, again, back to the EPTO possibility. And it's just a more robust, it can withstand higher current surges and hold up to that type of abuse. Obviously, everything is automatic on the system, including recharging. So if you're away from the vehicle and the vehicle the batteries are beginning to get to a low state of charge and needs to recharge itself, it'll automatically start the vehicle back up and recharge back up to a state of charge that it's a setting that we would agree together on what those parameters need to be. And at that point, we would just turn the engine back off again. So if your scenario is one where they're off providing service to your customer and the truck is there and it needs to be powered the whole time, then the engine will start and stop as it needs to, and your operator will not have to worry about that. It's taken care of for you automatically. Across the bottom row here, far left is the zero key. It's a feature that allows us to put the vehicle in a secure status and remove the key from the ignition while that work's going on. So you may have an application where they leave the vehicle and they want to leave it on, quote unquote, powered, and operating, but they don't want somebody to drive away with it either, right? It's got valuable tools or whatever, their lunch, whatever's inside there. They want to make sure it's there when they get back to it. So they're able to remove the key, secure the vehicle, go and do their job, and come back to a vehicle that's been powered and conditioned while they're away. And if someone were to, let's say that they're away from the vehicle and the battery is discharged to a low point and the engine restarts and someone breaks the window to get in to drive it away anyway, as soon as you put it in gear, it would just turn the engine off. So it's a theft deterrent system all the way to the end use of it. There's also some features that we've added. You've got these batteries on board. You've got a lithium battery pack on there. That's probably going to be typically in most work truck applications and like this will be our smallest system will be at a 2 kilowatt pack up to 10, 12 kilowatt packs based on what the needs may be for the application. And those scenarios, they're going to be used to power the vehicle as we've discussed. But even they will become discharged to a certain point, and they need to restart the vehicle again. And in some locales, some cities, I don't think it's a state law in most places yet, but some cities will actually put a bounty out there if they catch a vehicle idling that's not exempt. You can text a picture of the license plate, and they'll send you a fine in the mail. So zero idle allows you to put the vehicle in a mode to where it'll use the lithium power as long as it can. When it gets to a low point, it needs to start. Instead of restarting the engine, it would email your operator to tell them that their vehicle needs to start. If they don't come back and start it within a time frame, it'll just turn everything off. And so it keeps you from idling in a no idle zone where it's completely restricted. And zero draw is a feature we've added really more as we got into emergency vehicles and and some work trucks where there's just a lot of parasitic load on these vehicles now. Maybe, GPS systems, your telematics providers, it may be whatever, radios, you name it. That's got always on connections to your cranking battery, and if they're left without being used for several days, maybe they're waiting to be serviced or whatever. Someone's on vacation, they come back and the vehicle has to be boosted to crank because of the parasitic loads. That zero draw feature allows you to use that lithium battery pack and absorb those parasitic loads to a low point that you set within our pack. And then when it gets to its low point, it just turns all those loads off. So it simulates a dead cranking battery without having a dead cranking battery. You come back to a hot battery to start your vehicle with. Now, obviously, we talked about electric PTO. It is optional. It is something that would be collaborative design with either, the end user speccing it out together with their builder, whatever, because we don't get into the hydraulic side of things, but we would provide the power and make the motor that works best with our power system and the hydraulics that's required. So this is just another example of our screen and how that zero key feature would work. These little soft keys across the bottom here, if you look to that zero key icon is a green backlit key in the far right corner of the screen. The little round green circle beneath it is a soft key. When you press that key would turn green. You can remove the key from the ignition, and then you can use the vehicle in that secured fashion we talked about. On the far left, where that engine is there, the white engine with a line through it, is the zero idle feature. You would press that button. As long as that button's green, as long as that icon is green above that button, it would not automatically start the engine when you're away from it. So that's how your operators would interface with our system. If for some reason you don't want this screen inside your vehicle, there's one more screen is probably not welcome in anybody's vehicles these days. We can make those remote switches that we work with the builder to make sure that they're momentary switches that we can either build into the console, the dash, wherever it makes sense, and provide the same functions without the screen having to be inside the vehicle. So one of the things that Zero RPM has always prided ourselves on from the beginning of our company is we sell systems. We don't get into the drop ship business. When you buy a system from us and it's going to your builder or in your own shop for a retrofit, whatever, it's going to come to you in one skid with green shrink wrap on it that lets you know that it left our shop. There's not many freight terminals keeps green shrink wrap on their terminal yard. So if it shows up to you with anything but green shrink wrap, you know that pallet's been disturbed since it left our shop and come to yours. But everything on that skid is going to be accompanied by what we call a tech package, which would be theories of operation, diagrams, work instructions, best practices, standards and best practices for torque settings, things like that you can successfully install this system. And it is a completely integrated system. So we always bought, if we had a third party, like I mentioned earlier, fuel operated furnaces for cold environments, if we're using one of those, we bring it in and test it on one of our trucks and know how it worked and know how to make it, how to program our software to work with it before we ever sold it to a customer. And we would work closely with those suppliers to create relationships with them to provide the best service possible after the sale. This has become more true than ever because becoming a part of mission critical electronics and having sibling companies like Purkeys and Xantrax and Kuzmal, people like that, there's pieces of their technology in our system now that we don't have to go outside of our family of businesses to be able to provide this system to you as much as we used to. So from whether it be, of course, our energy is all in-house, the electronics, the control systems. We may buy a PLC. Our PLC is manufactured in Germany, but all the software and all is developed in-house by us. We control the design of those things. All the way down to the charging systems, the inverters, all that is all managed in-house. We use that inside the family. So everything that can talk over CAN, things like that to each other to make the installation simpler and to make the system work more seamlessly, we all can control that from inside the mission critical family. So we also know that fleets are not all the same size. They're not all made up the same way. So we've got solutions from a class 1 to a class 8, and everything in between. I will say that the form factor of our system and the price of our system and the business cases that's associated with all that, we typically end up being on a class 3 and up, just because, now the contradiction of that, there's a lot of transits out there that we're doing with our system because of how they're used. There, in many cases, we're working with utility companies or things like that, where those transits are about mobile workstations, and there's workbenches inside there, and all kind of bins for parts and stuff. And the system is tucked up under a shelf somewhere, and we're the air conditioning and the power while they're on site working. But typically we're going to be a class 3 and up in most work truck applications. But our software is the same if it is a class 1 as it is a class 8. It's the same technology, same batteries, same air conditioning compressors, same valves, same everything. And so scalability across your fleet and training your technicians how to support that fleet is much simpler because of that. Because whether you're on a class 1 or a class 8, the troubleshooting is the same. So we can also, we get into different power output needs based on the workload. So, we go up to a 48 volt output on our power and how we manage the power. It gets a little more technical as far as how you recharge that, because now we have to have a 48 volt power plant on the vehicle alternator to recharge the system if it needs to be recharged by the vehicle. In some cases, we just build those packs big enough to where they'll last the entire workday, and they're only charged by shore power or solar. So we can be very versatile how this whole system works and how we design it with you for the right application. But, getting close to the end here, we also understand that validation is very important. And we've developed an in-house tool that helps us validate that the system does actually perform what we say it'll accomplish what we say it'll accomplish. So you can look, and nobody wants to be the person who buys an expensive paperweight that didn't work like they thought it would. So we give you ways to in real time validate that we have solutions for the environments that you're putting it in, and you can bring that report back to whomever is judging that decision to say, yep, it's accomplishing exactly what we thought it would. But we also know that, again, we've been in business since 2012, so there are been incorporated since 2012, but a lot has changed since we've been in business. There's a lot of other ways to measure this. So another one of our poll questions that Jimmy wanted to ask was around that, about other tools out there that might be in use.
Yeah. Thanks for that explanation. So this poll question is, do you already have a telematics provider tracking your idle times? If so, who is your provider? Now, we're not going to, that's confidential information. We're not going to, present that here on this webinar, but we're just very interested in who your providers are and who you're working with. And like Todd said, that's who we need to be working with. So if you can list out who your provider is, go ahead, Todd.
No, I'm sorry, Jimmy. I thought you just threw that. The one thing that we are working toward is company. I'll drop some names like Geotab, Samsara, Verizon Connect, or some popular ones out there. And we are working internally with on our side to try to find ways to send the data through those mechanisms, so there's not two reports to have to get. You're not trying to cross-reference data. You've got one data bank or one source of data that you can go to get all the information you need for your management. So today, we do have our own in-house solution. It's not a profit center for us. We're not trying to sell you more data, more devices. We're just trying to give you a way to validate our system does what we say it'll do.
Absolutely.
So one thing we can do, if you do have that type of tool available and you have the data, we can make this process a little easier. If not, we do have a tool that Jimmy and I can meet with you on. It's something we would do together with you. But we can go in and ask you some nosy questions about how you use your fleet, and kind of walk us through a day in the life of the different applications you'd want to consider our system for. And we build a profile that basically we're backing into estimating how much you think you're idling. But in many cases today, again, through the telematics providers that are out there, You may know that to the decimal. If you do, that's fine. We can use that data that you already have and plug it in and still back into what we feel like the business case would be. What we use here, just so everyone knows, things like the annual fuel savings estimated here. On our presentation, we used a gallon an hour just to have something to run some math off of. In this scenario, we're actually using Argonne National Labs data for the chassis that you tell us. So we've got the database of chassis that Argonne has, and when we know the make, model, and year and fuel type of the chassis that you want to analyze, then we go back, cross-reference that to the Argonne Labs data, and we would pull their fuel burn rate that they have for that chassis, and the emissions rate they have for that chassis. And so it would be a lot more accurate than what we used in our presentation, which was just, to show you, give you an idea of how this can add up. This tool gives us a very, very close business case that you can go make a business decision based on purchasing our system for.
Yep.
But again, I mentioned
real quick. Sorry,
yes,
Todd. Real quick before you move any forward, I've got a good question from the audience that I wanted to ask.
Sure.
Ask you. Will other equipment on our service trucks be affected by moving to lithium batteries?
So, like, would the power output of our batteries be different than what they would normally see, like from the alternator, that type of thing?
Yes.
No, our nominal voltage for our batteries is like 12.8 volts. So your output power of your alternator is going to be around that 13 and a half volts when it's charging. So really, it's going to be as if the engine never turned off to the power coming in to all the DC power devices. The only thing one thing that it's not really exactly answering that question, but just in case there's some curiosity, many people who deals with lithium will require you to put a secondary alternator on board to power the lithium. Ours is designed differently. Our chemistry has been doped a little bit differently to run a little lower nominal voltage. So we can use the standard factory alternator system, and we use like a transfer switch, if you would, to manage whether those the alternator or the alternators plural, according to how the truck is designed. And we're pointing it either at our lithium or at the lead acid battery. And we can control which one of those are getting the charge. And so they're not blended together, and we can use the factory system to do our recharging with.
Yeah, got lots of good questions rolling in here, Todd. So the next one is, does your battery pack replace the existing power unit battery and any auxiliary batteries?
It would replace the auxiliary batteries. The existing power unit, what you would actually use, we refer to that as the cranking battery. The battery that's assigned to the chassis for cranking the engine, you would continue to use it for cranking the engine, but it would only be used for cranking the engine. Once you start the engine, that transfer switch I was describing, once you crank the engine, we would recharge that battery first. Once we measure that, and once that battery is full, we disconnect the cranking battery and point all loads and all recharging to the lithium, so that it's constantly being charged and discharged by the engine or by the power of the vehicle, right? And that cranking battery is basically disconnected until it's time to start the engine again.
So kind of going back to the last question on, will other equipment be affected? What about lift gates? And I know a lot of the testing that you and I have done, it works well with lift gates and it can handle the load.
That's right. Yeah, the battery pack size will determine some of this, but as a rule, our packs are designed to take up to like 3C of the capacity. So let's just say our smallest pack, 100 amp hours. We can take a surge of 300 amps, continuous. It's gonna discharge faster, right? So let's say a lift gate. Once we know what the current draw would be on that lift gate, we would size the battery pack to be able to to handle a cycle of the lift gate and maintain the air conditioning system and the lights, for instance, we would run a use case and say, okay, how much power do you need to get you through one of your stops, one of your intervals before the engine can crank and recharge the batteries again, right? So we would check, we would typically size our systems to be interval based. So if you have out of an 8-hour shift, if you have 4 intervals that the truck would be used in that scenario, we would size it so it can withstand the full interval and then be charged again while driving, and then go to the next interval. So, and if it doesn't work that way and your intervals are all inconsistent and packed too close together or whatever, then if you're on site and you're in the middle of running that lift gate and our batteries get to the low state of charge, we just start the engine and nothing's the wiser. Everything operates as normal. It's just whether the engine's on or engine's off based on the conditions of the batteries. If that makes sense.
So we got another one here, and I know you just talked about adding, sizing the system properly, but weight, added weight of the system. What typically, does the system weigh? I know it varies depending on what system you go with. But.
Yeah, a typical our smallest system, a 2 kilowatt system with air conditioning and all that, the full kit, harnesses, hoses, and all, or the skid. Let's put it that way: the pallet that we would ship to you is going to weigh less than 200 pounds. So everything on that skid would weigh less than 200 pounds to go on the truck. The actual box that the battery is housed in and the compressor is housed in, and how it would mount, where it would mount and stuff, that one box is going to weigh about 100 pounds of that total load. The rest of that 100 pounds is distributed around the kit on the vehicle.
Okay, and I kind of skipped ahead and started with a lot of the questions already. We'll do some more questions at the end here, which we're about to wrap it up. But one more for you, Todd. What is the typical payback period for your customers?
Well, that is a moving target. That's back to that tool we looked at a moment ago about, and I'm going to go back one slide just so I can help use that to describe this particular scenario we had here. They had a lifetime savings of $55,000. That was including PM savings that we calculated that you can reduce the number of PMs that you have with that vehicle over its life, fuel savings that you had, and then of course the amount of time that they told us they were going to keep the vehicle, right? So in that scenario, they saved over 10,000 engine hours over the life of that vehicle. And they had a 2.74 year payback time frame of this vehicle. Now, that use case is a lot of idle, right? It's probably a 24-hour truck. It's there's several things I can extrapolate by looking at this. We mitigated over 82% of their idle, so they can have a very if your intervals of idle is shorter than your intervals of drive, then the percentage of idle we can mitigate goes up a lot higher with a smaller system, if that makes sense, right? So in other words, if I'm idling most of the days, if I pull out to a job site and I idle continuously for 3 or 4 hours, I've either got to start and stop the vehicle several times while I'm there, or have a much larger battery pack to last the day, right? So having all that, that's why we want to talk to someone person to person and go through the different variables to come up with what that calculation could be. As a rule, if we can't come up with a business case that gives you a payback of less than 3 years, we're typically not the right solution for your, financially for the fleet. That has been my experience to this point. In some cases, it's different, right? So in some cases, the business case is they recoup the cost of the system over the life of the vehicle, which can be 5 to 7 years, but they've accomplished other goals, which is to extend to reduce the amount of maintenance required on the particulate filters and the exhaust systems due to the DEF and all the clogging that happens on diesel engines these days, right? So it could be that fuel payback is not really what they're monitoring. It's the fact that they keep the engine hours down lower and they keep the uptime is increased, so the revenue is better. So all that is really so case by case. It's hard to give you one answer.
Right. Okay. I believe that's all the questions
So
for now.
so the this is really the end of our presentation here. It's just to say we've been around for a while, right? We incorporated in 2012. We were a science project for about 2 years prior to that. We've 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 been the recipients of several innovation awards and recognized for the technology and the innovation of the technology that we've created. We're This map may be a little out of date now. I was told the other day we've actually got some in Vermont now, but as of the time we built this slide, we were in all states, 47 of the states except for Vermont, Montana, and Alaska. So we've got a variation of extremely hot climates, extremely cold climates, and it seems like everything in between, and many different use cases. Back to what I said, where it may be systems that's idling all day long. They go out to the oil fields and they stay there all day long, and they're just all they are is a refuge, a power supply to what they're working on, and a refuge from the heat. So all the way to people who are like an ambulance that makes 25 stops a day. So it's just we've got a pretty broad diversity of our system applications, and once we can have a one-on-one conversation and talk through the different scenarios, we typically can find the best use case for you, or tell you that we don't have a good solution for you. We're the wrong solution for you. Last thing we want is to sell somebody one time and it's the wrong solution. We would a lot rather sell you products for the next 20 years, right? So because we are the right solution.
And that's where that tool comes in handy, Todd. You really kind of show them, work together, and come up with the numbers to see if it makes sense.
Absolutely. But that's really down to any other questions now.
Yeah, so we're going to open it up to the. I know we went through a lot of the questions already, but I'm going to open it up to the audience to ask any additional questions. Please stick around, after the webinar to fill out a brief survey. Let us know what you thought of the webinar. We're always taking ideas for new webinars. So if you have any ideas on anything you are interested in hearing us talk about, please submit those. But yeah, send some questions in. We'll try to answer them for you.
One of the things that I want to try to answer without sidestepping it too much is what is the auto mitigation cost, right? What does the system cost? Truth of it is, we can provide, and we've got systems out there working that we can provide very impressive percentages of idle savings for $2,000 or $3,000, $5,000 maybe. You put lithium on board, it immediately adds more expense than lead acid, of course, not really because of the lithium itself, but all the electronics around it that you need to manage it with and do it properly. And then output power for 110 loads, things like that. But we've also got systems that are, $50,000, $60,000, right? And in the use case and the business case are also custom. We really need to have a one-on-one conversation to get into those details to give you the right information.
Here's an interesting one, Todd. Is there a minimum size alternator required? I know, sizing an alternator, you got to really take a look at all your loads and your power demands. But is, for your system, is there a minimum requirement as far as the alternator?
Absolutely. Yeah. Our goal, now I'll try to get too technical with this, but our goal is always a 1-to-1 ratio. So if the discharge rate of your vehicle, when we put it in auto mitigation, right? So engine off, everything's on. You put a clamp on meter on your battery terminal, and whatever that current draw is, you need at least that much power coming out of the alternator. And if your vehicle's operating and you're able to drive it around with all those power loads on, it's typically going to be a 1-to-1 ratio, right? So we're able to get it. So you at least want at least a 1-to-1 ratio. But what we really need is a 2-to-1 ratio. So if it takes let's, again, simple math for my country mind. Let's say that your load on your vehicle that is required to operate is 100 amps. And if you have a 100 amp output on your alternator, then there's enough to carry the load of the vehicle around, but there's not enough to recharge our batteries unless you turn some things off. And a lot of times that 100 amp load is not consistent, right? It ranges from 25 amps to 100 amps. So anytime that your load of the vehicle starts to go down, we've got more leftover power to charge our batteries with. Ideally, like let's take an ambulance, for instance. An ambulance has a ambulance package on their alternator. So they'll put, like, let's say it's a Ford, just because we do several Fords, or a big Freightliner, for instance. They may put 2 big dual alternators on that thing that can put out 300 amps each, right? Because they got so much power on the ambulance. Well, we'll use that extra power. So if the load of the ambulance is 200 amps, but I got a potential to charge at 600 amps, then when we crank that vehicle back up, we can power the vehicle and actually have 400 amps left over to come into our batteries to charge them faster. So the minimum size that you would want to operate is you'd want to do a test and see how much power it takes to operate your vehicle, and then make sure that you're not having to pull power out of our batteries when the vehicle cranks. But the more power you can give our batteries, the faster they'll recharge and shorten the idle time that you experience, right? So you can have too much alternator. You can have too big of an alternator based on the battery pack size. But when we're working together to help you size the right system, your charging source on the vehicle will be part of that conversation and helping you make the right decision, either when you're speccing out a new vehicle and speccing the charging system that would come on it, or whether you're identifying maybe an aftermarket alternator that you want to do a retrofit on or something like that, right? So those are there's definitely part of the conversation.
All right, thank you for that. All right, I don't see any more questions come in.
I will add this, because of the nature of the questions. I want to say that the 0 RPM system is not a light bar. It's not an inverter either, right? It's a fully integrated system that helps you manage how your vehicle is used and abused potentially, right, due to idling. So it is a conversation from bumper to bumper that we'll have about that vehicle and make sure we understand the chassis, as well as the upfit, as well as the use case. And so we'll be a part of the design of the vehicle. We won't be added on after the fact. And if we're a retrofit after the fact, that same conversation has to happen to know how it was designed, how it is currently being used, and how the upfit on the vehicle affects the vehicle itself, weight, power demands, things like that. So it'll be a collaborative decision when we size the system, and everybody involved to know what those puts and takes are, right? What's the discharge rate? What's the recharge rate? How do we want to recharge it? Solar, shore power, engine only, all those decisions will be collaborative with the end customer.
Yeah, I'm glad you said that. There's always corner cases, and I've sat through a lot of those questions that you guys ask at 0 RPM, and similar to what we do here is catching all those corner cases and making sure we size it properly.
Certainly.
All right, we're close on our time. I want to thank everybody for joining the webinar today. If you're interested and want some more information, please reach out to us. Again, don't forget the survey at the end of the webinar. Let us know how we did. Let us know any additional information you want. And yeah, thanks again for joining us today.
Yeah, thanks everyone.